And the thing we have to think about when we consider the phases of the moon, which is how we see the moon at various times throughout its orbit around the Earth, we have to consider that it's a three-body problem. There's a source of light, which is the sun. There is the moon, which reflects that light. And there is the Earth, which can view it. And so one of the things we have to think about is also is that this could be reversed around a little bit. We could have the sun being the source of light, the moon being the location where you're observing from, and the Earth being the object being illuminated. So from the moon, the Earth would go through phases, and from the Earth, the moon goes through phases. Now, the important aspect of that is that both of those bodies, the Earth and the moon, they are not emitting light that we can see. The sun does. And so the sun is extraordinarily hot, and light is traveling away from the sun, and the moon and the Earth are only reflecting light. So that's why an object can go through phases, is if it does not emit its own light, it only reflects light. So to consider how this works, in the case, we're going to go to turn the lights out and look at the moon here. And if we look at this source of light coming from your left, and the moon is there, and we can see that the moon could rotate with the light shining on it. That's not a problem. But what you see is that you are not able to see it fully lit, unless the source of light is coming from this direction, in which you can see that it is fully lit. Likewise, if we move around here, we can see a variety of different amounts of light shining on the moon. And so we have names for these, and so that we'll begin in this position where the moon is dark from your point of view. Now this would be simulating an eclipse, but we don't always have an eclipse when we have a new moon. This would be the case of a new moon, and you can see that the sun is very bright, but the moon is very dark. But after a few days, the moon progresses around the Earth, and as we view the moon, it appears as a crescent moon. And over here, this is called a quarter moon. And when it's like this, and you can see more than half lit, but not fully lit, that's called a gibbous phase. This is full. And then it repeats like this. Okay, so some of the more important ones to remember is the quarter moons, and that's the half lit and half dark. And one thing I want to emphasize is if you're, let's say you're making a sketch of this, you would want to start a line beginning at the top and drawing a straight line down to the bottom. But that line from the top to the bottom is always present, no matter what phase you happen to be in. But then you have a curve depicting the moon. But you can see it's all because the moon is round, the source of light is coming from the sun is far away, shining on all over the moon, and half the moon is lit at all times, half the moon is dark at all times, and we'll move through phases here. Half of it's lit and half of it's dark, but the viewer sees a changing amount of light as the angle changes. So if we go through this cycle one more time, where we start at the new moon, and we define a couple of things. The crescent moon is when it's a very narrow shape. It's kind of like a banana shape and less than half lit from your viewpoint. Then we get to the first quarter, that's half lit, half dark. And the waxing gibbous, as the moon is getting brighter from your viewpoint, we call that waxing. So you would have a waxing crescent, a first quarter, and then a waxing gibbous. Then you get to the full moon. Then you go through a period of waning gibbous, third quarter or last quarter. That's optional either way. And then waning crescent, finally to new moon. And this whole cycle of phases takes 29 and a half days, which if you round that, that's 30 days. And this is, think about, well, 30 days is a pretty good number. If I multiply that by 12, I get 360. So again, 360 degrees in a circle. Roughly, that's how many days are in a year. So that means roughly 30 months, 30 days per month for 12 months. Okay, so to do this, we'll begin over here. We'll go, this is the new moon. This would be a solar eclipse. But we'll start here with new moon. This don't have an eclipse every month. And then it begins to be seen night after night. After about 3 or 4 days, you get here. After, this is a waxing crescent. 3 or 4 days in so far. Then you get to first quarter. Notice that it is lit on the right and dark on the left. This is how we would view it in the sky. Right here from Las Cruces, we look up and we see half lit on the right, dark on the left. That's the first quarter moon. Then it continues. We see the gibbous phase, where much of it is being lit now. And then we get all the way to full moon. Which is about right here. And then it begins the process of waning now. These are waning phases, no longer waxing. Waning gibbous. Third quarter. Waning crescent. Let's go back. Waning gibbous. Third quarter. Waning crescent. and then ultimately new moon again after 29 and a half days, or 1 month, which I think is really the proper way that we should say month, because the month comes from the moon and specifically the phases of the moon. And remember that the phases of the moon, 29 and a half days, that period is not the same as the rotation period of the moon or the spin period of the moon. The orbital period around the Earth. The orbital period around the Earth is equal to the spin period of the moon, which is 27 1/3 days, whereas the phases take 29 and a half days. All right.